In panel B, we'll repeat the analysis, but this time we'll assume that housing is a quasi-linear good. Quasi-linear goods don't have income effects, and thus point C will be the same as point B, because the only difference in this demand graph between B and C is the income effect. Connecting A and C gives us our own price demand curve. Connecting A and B, on the other hand, gives us the marginal willingness to pay curve for the indifference curve that contains bundle A. Since B is equal to C, that marginal willingness to pay curve now lies right on top of the own price demand curve. This should make sense. The only difference between the own price demand curve and the compensated demand curve is the income effect. And here, for a quasi-linear good, we've assumed that there is no income effect. For the same reasons as in panel A, we then get that the deadweight loss is equal to the shaded area beta. There is no shaded blue area gamma in this case because there's no difference between the demand and the marginal willingness to pay curve. Thus, in this special case where housing is assumed to be a quasi-linear good, using the own price demand curve to estimate the deadweight loss triangle beta does not create an error because the own price demand curve is the same as the marginal willingness to pay curve. In your Principles of Economics class, you probably learned to estimate deadweight loss triangles from taxation along own price demand curves. We can see here that that's actually accurate only in the special case where the tax good is a quasi-linear good. When the tax good is a normal good, using the own price demand curve to estimate deadweight losses will cause us to overestimate those deadweight losses and thus the inefficiency of the tax. If the tax good is an inferior good, on the other hand, using the own price demand curve will cause us to underestimate the deadweight loss and thus underestimate the inefficiency of the tax.